Hey everybody, it's Chris West and Jim Bradley.
Hello, everybody.
House Calls Vermont. It's Tuesday evenings, and tonight we're going to be talking about embodied energy and what that is. We got an interesting show lined up for you tonight. Jim and I will be talking for a while about not only what embodied energy is and how it affects how we make choices when we're looking at materials. Also, carbon sequestration. Ooh, that's an important word.
Sounds like
Uh,
you did something wrong, Chris, if you're screen.
that's right. We're sequestering something. Somebody did something wrong. They're in the what is it that the quiet corner or whatever that was that we were that wasn't around when I was a kid. You just you know
You
you got
lumped it. Yeah, exactly.
so we're going to be talking today, and oh, sorry, just to finish up. After we have that discussion, Jim and I will be passing off. We've got three pre-recorded segments tonight. First, we're going to be looking at an update from 10 Old Stage, what's going on there. Jim came out this last weekend, and we looked at the window bucks, so we know what we have to do to get those ready. Should be getting the windows delivered this Saturday afternoon, and then next week or the weekend after that, Jim and I will be doing a special video on the proper way to install these windows and how to make sure that we're doing the flashing right for bulk water and also vapor open tapes and things like that. And we'll have Mark Coviello also involved from SIGA to show us the various tapes that we might want to use for that type of thing. Jim's got some of those tapes, so we won't have to necessarily buy them. And then after that, just the last installment of the energy audit eavesdropping. This is the final part of the audit where Jim and I chat about the findings that we've had during that audit and the basic recommendations, which of course will then be followed up with a report about 2 weeks after the audit. Yes, it does take 2 weeks. I just have way too much going on to spend the 2 to 3 hours to get that report ready right after an audit. So I stretch it out. And a lot of companies make sure that their audits are out right away, but they're never as comprehensive as our audits. So we take our time and we do it right, as my aunt used to say. So after that, the interview this week is with Jacob Racusin, who is one of the well, what do you say when
Principles.
a
One of the principles.
company, yeah, principals, I like that. Co-owners, it's a cooperative ownership model, so principles works. About embodied energy, and embodied energy has been one of Jacob's important topics, and he's done a lot of research in it. He's written a couple of books, one of them specifically about embodied energy and about natural buildings. He's working on developing tools that we can all use to figure out what the carbon footprint is of a building based on its materials. So, but we'll describe exactly what that means as we get into the discussion tonight. So, how's it going, Jim? What's I know that you've had quite a week, but tell me how things are going there up in Cambridge.
No, things are going well. Just there's plenty of things to talk about. We were earlier on the meeting. You were there as well, but with Vermont, as far as their workforce weatherization collaborative, and talking about the details and how we go forward, and we tend to diverge or get directed in different directions because this is such a big topic, in our country, as far as how do we move forward in doing the right thing when it comes to building science in our building stock and using resources appropriately, resource preservation and not wasting. And how do we find people to be engaged with that? Because a lot of that work, doing it appropriately, is not the most glamorous work. Let's put it that way. I've never been in an attic with a respirator on and mice going around and everything else and say, just like being on the beach. You never have that feeling. So it's
Well,
just
well,
something.
I do. You don't understand my relationship with beaches, but that's just my internal stuff. We won't go there.
Okay, well, Chris would never say, "What a lovely cloudy day in the Netherlands," because
There
I'm
you
so
go. Nice,
happy.
cold, wet, rainy day. That's what
Yeah,
makes me
exactly.
happy.
So you don't usually say that. So getting somebody engaged in that to see, okay, you're in the process, so stay in because there's a greater purpose of making this building sound, whole, the building occupants healthy, and a structure that's going to be durable for a long time to come, as well as using a lot less energy in the process, so we're not wasting more of our limited resources that we have on the planet. And with that, we're talking about embodied energy this week. And one thing that comes to mind, you start doing these topics, it's just amazing what happens when we get one of these topics that Chris and I start reviewing, and what we're going to do for the next week, or we're talking in that workforce weatherization meeting, and they were talking about supervising the job appropriately and making sure people are safe. And yet, just driving along today, I see something that was a complete violation of code. There's no enforcement right in the middle of downtown Burlington with lead paint removal. And you could tell the people working on site, this might have been one of their first of a few jobs they've done like this. They were working hard, great for them, but there was no proper PPE, no personal protective equipment in place the way it should be. And there was no recognizable supervisor on site that was watching that and monitoring that. Plus, you had cars going by on a nice Vermont 70-degree day with their windows open as they're scraping lead back and forth, and so you see that type of thing. So part of what we're doing in this mission of trying to get people to not allow bad things to happen and also do the right thing, because we're all trying to go in the same direction here. You come up with stories like this, and you see this, and you see that, okay, here's some pushback. But there was one customer that I was reminded of when I was thinking about this whole embodied energy thing. He was an environmental law lawyer who was teaching environmental law, and he had a LEED certified home on top of a wonderful mountain in Jericho, Vermont, and beautiful home. It was basically about $1 million home. And he tried to make it as green as possible, if you will, but it came time to sell. And when it came time to sell, he had to do some rehab after only 3 years. And his cedar siding clapboards on the outside were failing. And so
So describe for a second what that is. Cedar cider failing. What does that mean?
Okay, the cedar siding. So he had different. He had cement hardy board panels that had a stucco look to them, and they were 4x8 sheets. And he had those up there with there's different motifs there on the side of the wall. And so in other areas, he had horizontal siding. And the builder put cedar clapboards on that were horizontal beveled siding, and they sealed it only on one side with an interior polyurethane, not an exterior. Plus, they attached it with finish nails. So it only had one choice but to cup towards the sun and start pulling away from the nails. As it did, it basically was ruining the siding. So he wanted to sell this. He wanted to replace the siding first, and he had us out there. He said, "I want something more robust, more resilient." I said, "Well, what would you like to go with?" And he said, "That Ipe, whatever." I said,
"Oh,
okay.
You mean cut down in the rainforest Ipe?"
Exactly, that's what I said. And he says, "Yeah, exactly." And I'm sitting there thinking, okay, we're gonna go from Brazil. We're gonna use all the energy that it takes to cut down one of those trees, get it harvested, get it processed, get it shipped from Brazil to here, get it trucked up to Vermont so that it can then have the labor to install it. At the same time, that's embodied energy. That's getting the resource to the job site ready for install. The difference is what they're not looking at in embodied energy, from my understanding, is the fact of where does it leave the renewable resource, in the sense of how quickly will those trees grow back, if at all?
So the deficit in carbon sequestration that
Yes.
the tree itself represents. Yeah.
Exactly. So, I mean, embodied energy is part of the equation, but you also have to look at, if I just clear cut the whole forest, sure, timber looks good because it has a lower embodied energy if you're harvesting it regionally. But if you're doing taking from
regionally and sustainably.
Exactly. So that's not sustainably if you're just clear cutting. And so that has to be part of the equation. But what got me is, here we are trying to move forward. We have an environmental law, who became a professor, and he's basically making these choices to use the most, not comprehensive, but intensive embodied energy type of material that he can use instead of sourcing local cedar or local hemlock.
There you go. Go to the lumber yard down the street.
Exactly, which would be much better and would help your narrative at the same time. And so, that's some of the things that we're working against. So, part of this embodied energy component is when we look at spray foam. If you look at spray foam, it has its place, I will agree. But I don't think we should use it as fill all in all, and it's a wonderful solution for everything. because it has at least 100-year payback just to get it to the job site. So that means to manufacture it, to ship it, and get it to the job site, it's about 100-year payback before you ever install it because of the embodied energy weight that it has on that type of material. Here's another example. If you have a cell phone, one of the modern day cell phones, you realize that the embodied energy used to make that, you can actually, that same amount of energy, you can charge that phone for 50 years. So that's how much energy is used just to make one cell phone, and yet for a 50-year recharging cycles. That's pretty intensive. And so
Yeah.
we have to be really intelligent about what we're doing, the choices we're making, where are we going to source things. A lot of people like to be organic, but then they want to go ahead and go into the store and find all the different fruits and vegetables starting in 9 because 9 is organic. But you don't find out till later that may come from a foreign country way across the ocean.
Yeah.
And the reality is, by the time you actually get it to the source, you spend a lot more money getting it there instead of going with a local grower. And at the same time, the efficacy of that nutrients inside the fruit or the vegetables has completely diminished. And you don't get the same value that you think. You get the same label, but you don't get the same value. So being intelligent on how we choose our products, whether it be for building, whether it be for food, whether it be for clothing, let's look at where we're buying this from and what it takes to actually get it to the site. And that's what's really important, I think, Chris.
Yeah. So, but I think I think the term of what Jim is mentioning is called transportation miles, right? How
Yes.
much energy? And I had this discussion with an architect earlier today. We were talking about. He was like, "Well, I like using these European windows, and I think they're great." And you're not going to get an argument from me as
Sure.
far as what the American market has to offer, price per square foot. The European super insulated triple glazed windows, whether they're UPVC or they're wood or there's some other material, they are far better performing. However, how much bunker fuel are you putting into a tanker to ship them over? And that's where we start supporting a company like White Windows or Sierra Pacific or these other companies that are making that quality of window here in our own country, so we can cut down on the miles added to them. But I wanted to just take a moment and take a look at what is embodied energy. So a very 30,000 foot view. And so I went online and I found a graphic, and this graphic basically is saying that if you're looking, and this is for a house, right? This is the one of the graphs that shows us that red portion right there is the amount of energy that was required to harvest and produce and manufacture that product. 1% is the distribution, and the design is 5%. So wholly 15%. And it, of course, it changes and depends on which individual material you're looking at as to how big that 15% wedge is. And then the rest of that is 85% of it is the use of the house during its existence, right? So you have a house, you're building a house, your choices on materials, if you're basing it a little more on the embodied energy side, can drastically reduce the overall carbon footprint of that building over its lifetime. And of course, making that building super energy efficient will make any building that isn't built to that standard look like it's not, that it's using more energy during operations. So approximately, and I'm sure that if I could have Jacob Racusin, whose interview we'll be looking at later today, whispering in my ear, he could correct that with some kind of much more in-depth knowledge that he has. But basically what we're talking about is when you're choosing your materials, are we choosing materials that are made of plastic? Plastic has a very large embodied energy footprint. Something like an XPS or a polyiso. The polyiso much less than XPS. XPS is like the worst of the worst when it comes to insulations. But they're all not as good at EPS, XPS, polyiso as a wood fiber product like the Gutex or the products that GoLab are building up at Timber HP in Maine. So what is the embodied energy? An embodied carbon is a part of that. So we want to make sure we talk about both real quickly. Embodied energy is the amount of energy it costs to put it into it, and embodied carbon is the CO2 equivalent of that process. So, for instance, concrete, we've talked about this a lot, concrete is a great product, but in order to make it using the processes that we have available to us now, who knows in the future, but right now, you have to bake the material that becomes Portland cement for something like a week with gas furnaces blasting it the whole time. So if you're
At
going to look at
2,500 degrees.
yeah, it's a very, very hot, and what that changes the molecular makeup of it and makes it so that when you add water to it and mix it with an aggregate, it solidifies after a while, and it's going to take any form you want. It's an amazingly versatile material. It's incredibly strong, especially if you put rebar in it. This is a great product, but it also takes a huge amount of carbon dioxide equivalent, and once again equivalent, to produce. And when I was talking to Jacob, he gave me a great breakdown. He says embodied carbon equals carbon dioxide equivalent equals greenhouse gas equivalent. So what we're really saying when we say embodied energy is carbon dioxide, the nitrous oxide family, which is called NOx, NOx, because there's nitrous oxide and there's NO1, NO2, NO3, different nitrous families, and sulfur dioxide is another byproduct. So these and some other ones, right? We can definitely talk about mercury and other kinds of things that come out of some of these processes. But when we're talking about embodied energy, we're talking about creating a title that we can use that is actually an equivalent title, right? We're not saying we're going to count every molecule of carbon dioxide that goes out, because it's not just carbon dioxide that matters. We're also talking about the fuel used to transport it, and so when we're looking at materials, we what we want to do, we want to start taking that into account. We want to start saying, wait a second, is there a way that as I'm making my list of materials for building this thing, and because we're talking about houses and multifamily buildings and buildings in general on the show, we're talking about the building materials. And some building materials, you just can't miss them below grade, like concrete. I'm sorry, but find me a material that can be strong and work well for a long time in contact with wet ground, and it doesn't get much better than concrete. So we still, until we can find a better process, we still need to use it. However, let's only use it where it's really necessary. Let's not. I had a student in a pass house class I was teaching earlier this month, who said he wanted to build an ICF house, which basically is the insulated concrete form. So you have a piece of EPS here and a piece of EPS here, and there's a connector, and just put them down in their form and insulation at the same time. And my main objection to his plan was just the embodied energy of the concrete. As a building product, I think it's great if we can find a way to make it so that we're not using all of this, that it's not the most intensive carbon dioxide or embodied energy material in the entire industry, next to steel. But steel is a special case because steel can be completely 100% recycled. However, we do build some buildings out of concrete, and we do build some buildings out of steel, but those are usually the very large buildings, office buildings in cities and things like that. But when we're talking about embodied energy in a single family home, it's very easy to identify that. And Jacob Racusin and other people he's working with have come up with a calculator. It's not quite available yet, and as soon as it is, I will make it available, that you can put your materials in and see what the options are and how that affects the overall carbon dioxide energy balance or the embodied energy of that material.
And one thing about concrete, Chris, is the fact that, granted, this is not a hooray moment, but this is a good moment, is the fact that concrete does have an ability for carbon uptake. And, so some of these buildings that have been made of concrete, or the foundations, they do take up some carbon, just not to the point where we can say, that's a solution. It's more so it's something better than just a negative effect in that regard. Just as a point.
And there are technologies developing all the time where we're finding out that we can get to those temperatures using solar furnaces in Africa, or we can use a different mixing material which shortens the amount of time that it has to go through that process. So we're not the end of concrete. We've got a long time to still
No,
learn.
and to be fair, the concrete manufacturers are actually doing carbon capturing on many of their mills now. They're making the mills themselves more efficient, but they're practicing carbon capturing and getting better at that because they realize that if it's going to be promoted, it's got to come up with something that's going to work really well. So that's a good thing. One thing in the process is, with plastics, these plastics that keep going around, and we keep using single-use plastics that will, we may drink out of that bottle for 5 or 10 minutes, and the next thing you know, ooh, that's going to be around for hundreds or thousands and thousands of years, and before it ever goes away. And it puts a lot of stress on the environment, especially with the microplastics that get into our water, our oceans, whatever else, and our bodies at the same time.
Yeah.
And yet, so, you would think an easy solution would be, let's go back to glass, because glass will be able to not have that problem. It doesn't leach out into the glass, into the fluid from, whatever you have in it. And that's good. But then people say, well, the embodied energy of glass is so much higher because you have to transform a material, in the furnace once again, melt it down and get that there. But I think, to be real about this, part of the equation with embodied energy is not just what you're doing where you're harvesting, like we mentioned before with the forest, that you're leaving something unsustainable. But you got to look at, not just the first part of this understanding of how to do a process, like, okay, I can create a plastic bottle and that's going to use less energy to do that. What does it take on the other side to properly dispose of that? What energies are involved? What efforts are involved? What hazards are produced by what you're creating? So looking at every side of the equation, from the alpha to the omega, to the beginning to the end, that you're looking at this thing and you're saying, okay, from process 1 to process Z, are we looking at this appropriately and saying we're doing this responsibly? Now, granted, some people you can get yourself in mental gymnastics trying to do that, but a lot of these solutions out there have been around a long time, and we just have to be more intelligent about it in the way we're choosing. That's why I think with Jacob, he's looking at these natural resources to be able to be used as renewable resources that act as carbon sinks or carbon, sequestration components that allow for a much more positive aspect to our environment. And that's something that we really need to be aware of and consider more often.
Yeah, and from my point of view, I'd really like to live in a house that, if all human beings disappeared, would not be recognizable in 100 years. It would all just be composted back to natural materials. And I don't have that right yet, right? I've got all kinds of plasticized insulation around my house and things of that sort. So we're moving in the right direction. That I had a discussion earlier yesterday with an architect saying, wouldn't it be great if on this project we already had the timber HP products ready? Those are going to be available, the board product, in late 2022, third quarter, I think. So we're about a year and a quarter out from having a local sustainable supply of fiberboard insulation, which has the same R value as EPS and is acting as a carbon sequestering. And what do we mean by that? We're cutting down the tree, we're turning it into pulp, we're turning that pulp into an insulation. That insulation is going on the side of your house. It's like building a log cabin without all the leaky. Right?
But at the same time, I know you said it would be great to have a building that would dissolve at the 100-year point, but part of even the passive standards that we're looking to build.
No, I didn't say dissolve at the 100-year mark if we're still living in it. I'm like, if all humans disappear tomorrow, and no, I want my house. If we're going to build houses, we want them to be designed for at least 100 years, and probably for 2, 3, 400 years. I spent 10 years living in Europe. There are people in Italy living in houses that are from the 500, 600 AD. So and most of those are made of stone. But no, I wanted to clarify that. I want my house to be very durable. But if everybody disappeared off the face of the earth, there's no more people in it. That it would not be something that would be easily discernible as a house in 100 or 200 years.
Yeah, there's a neat story about being responsible well before their time. There was a college in New England. I want to say it's Amherst University. I could be incorrect, but I know it's in New England. when it was first constructed, they made one of the grand hall meeting halls, and they had these huge timbers going across the ceiling. It was just an exquisite ceiling. And it was back, I want to say 80s or 90s, it started to need major repairs. And this was, definitely well over 100 years old. And yet they're looking at this and say, okay, where are we going to find the historic trees this long, this big, to make this happen? How are we going to replace this? And when they were contemplating this, and as somebody was walking around on campus, they're looking at this untouched stand of trees on campus that was there, and it was the same species, and yet they were at the right height and the right size and everything else to be repurposed or reused, harvested, to be put in place in that hall, because they found out when they went back to the records, somebody was smart enough at the time to replant, to make it sustainable, and to make sure that resource was there, because they knew it was going to happen. So somebody was a bit ahead of their time. And yet that was responsible back then, before they realized what the pitfalls could be in our current modern day. And yet we could learn from that, certainly. No sound. Hey, Chris, if you can hear me, I don't hear you at all. Okay. Huh, interesting. Okay, interesting.
You're right. My mic was off because I coughed. Oh,
There
I
you
was
go.
talking all that time. I'm sorry, everyone. I coughed. I didn't want you to hear my cough. So there are resources that you can get high level embodied energy numbers. But we're gonna things that have a lot of embodied energy: steel, glass, concrete, and plasticized insulation. And we're talking about things based on what do we need to make a building. The plasticide insulation goes from XPS being the highest global warming potential / embodied energy, and then coming down you've got polyiso and EPS, which are pretty close to each other, but spray foam being above both of those significantly, and then down from there we get our cellulose and our exterior wood fiber insulation. Rock wool is up there. It's pretty energy intensive to make rock wool. Great product. We like using it. But it does take quite a lot of energy to make that material. So if we were to look purely from a embodied energy and carbon sequestration point of view, we'd want to use all of those high embodied energy materials as sparingly as possible and only where they're best to be used, and then start using our natural fiber based materials. Jacob's company, New Frameworks, is making something called a Griffin wall, which is a panelized straw bale wall. And a straw bale wall is a good R40 wall, right there, which is for our climate a pretty good starting point. That's the high performance number. So it's a thick wall, and when I first started doing this work, people were like, "Oh, no one's going to want to live in a house with the walls that are that thick." And I'm like, you know what? You get used to it. It's not that you're not in a cave. People are worried about that. They have window treatments where they angle the windows to let more light in around the windows. So and an Adobe interior is just definitely a personal feeling, whether you like that or not. But I'm a big fan. So that's moving towards all natural materials is kind of where we're moving. We're starting to see. Wait a second, these plastics, they're around for a long time. They leach into our waterways. They have sometimes they have that biphenyl alpha and beta in it, which are estrogen mimicking chemicals that can screw with our bodies in ways that we barely understand at this point. And we're just doing this big experiment with it because it seems perfectly fine. And I think Yeah, glass takes a lot of energy to reform, but it's also 100% recyclable. And there are lots of things that can be turned into. And if all we have to do is add energy to it, then maybe we can add energy that's produced in a way that isn't burning something, right? So maybe by the time I've been dead for 50 years, we'll start getting towards that. I hope that in the time in between now and when I go, knock on wood, that there will be a lot of products moving us in that direction. I think Glavel is a great example. This is a vitrified glass below grade insulation material that we've done an interview. I think it was in episode 3 of the live YouTube videos. It's also an interview on its own with Rob Comboy, and I would also highly recommend looking at the interview, not now, not during the show, but with Scott Dione from Timber HP, talking about that wood fiber insulation that's going to be making up in Maine. So yeah.
And there's one thing too, that there's another type of insulation that we have.
Teenagers.
What was that? Oh,
my teenagers just came in.
One thing
saying,
we have.
Hello. Go on, Jim.
Well, I was just going to say that, along with the wood fiber, there's something that I've only become aware of this week. And, you're in this, in depth all the time with this whole business. But then something comes along you realize you hadn't heard about before. But it was the mycelium, which is basically made from mushrooms. And I cannot stand mushrooms in cooking. But finally, they have a redemptive value. But not only for containers, for like single-use containers for eating, but the whole thing with it can grow insulation board that actually has a better thermal benefit than plasticized insulation. And this is not just an idea or a concept. They've already had proof of concept. They're already producing this. It's already working. And once again, they say, well, the plastic containers that you use to put food in or ship things in, like wine or glass or whatever you need protection for, they say, well, it's a little bit higher price than polystyrene. Okay, so it's a little bit higher. But what happens to that polystyrene? You can't recycle it. It's in the landfill for basically forever, and it hurts the environment. But you've got this other type of thing that is grown out of, the fungus from, a mushroom, basically, in a form, and it's just streamlined. It works so well. So it's basically having that end of life cycle effect that it has on the environment. It doesn't, because within 45 days of one of those packages being on the ground, exposed to the elements, it's gone. So Chris said, within 100 years, if everyone was gone and he wants his house gone,
here's the mushroom. It reminds me very much of the Smurf village, right? They're all living in mushrooms. So the mycelium is something that I first heard from Jacob at the Better Building by Design something like 5 years ago. And he was talking about there's a lab that's been researching this, and part of what the lab is doing is they're trying to find out if there's a way to have a spray on where you go and you spray this mixture of mycelium spores, which is mushroom spores, and some kind of growth medium onto the wall, and then it will grow to the thickness that you need. You shave it down a little, and there's your insulation. And each one of those, one of the reasons mushrooms are so light, and one of the reasons that mushrooms are so light when you take the water out of them, they're pretty much just water and cell walls, and that is air pockets. And that's what insulates. What insulates is trapped air or trapped gas of some kind. In XPS, it's going to be a trapped blowing agent. They've been using carbon dioxide lately as a blowing agent instead of some of these other more harmful blowing agents. But it's trapped gas, right? That's why wind washing is a bad thing, because the wind blows the air that was trapped in the insulation that was warmed by the house out and replaces it with cold air, and then it has to warm up again. So mycelium, if we could get back to a society where every container was either made of glass or metal or some kind of plant material that is reusable, and by plant I'm including mushrooms, even though it's not officially in the plant kingdom, and that would be awesome. I would be 100% for that. Pepsi, there was a horrible moment last year where Coca-Cola came out and said, we are not going to stop using plastic bottles, like stamping their foot down like an angry 3-year-old. And then Pepsi came out and said, we're doing research on doing a paper can, a can that's actually a type of paper that will hold the stuff and will be cold and the whole thing, but when it's done, it's just paper. And that's what we have to do. We need to move towards that direction. So we're about, go ahead.
Even in your cans, though, a lot of people don't realize this. Go on a science show where they dissolve the can, and what's left over in soda cans, in beer cans, in a lot of your regular cans that you store your food in, regular tin cans as we call them, those inside they have a plastic liner.
Yeah, they've been coating them. Yep.
Yeah, and they're not BPA free, so you're throwing that can away. Think, it's a recyclable material. There's still plastic in there.
Yep.
And that's going to have an impact on the environment. So that's just something I wanted to add, Chris.
Yep. No, that's cool. So that's our little chit chat about embodied energy. Please stay tuned. Please stay tuned for Jacob's interview, where he's going to go a lot more in depth into that from a much more studied point of view. But first of all, we're going to start by checking out the second episode, or the fourth episode of our energy audit eavesdropping, where you guys got to watch me and Jim during an audit. And this is the last bit. It's about a 10 or 12 minute bit where Jim and I are wrapping up the audit at that house in Isle of Motte and discussing what we're going to do in the future and the report and things like that, and what we found and what we thought. So let's go to that. When we're at a place doing an audit and we are able to talk to the client about some of these building science things, like hot air rises, heat doesn't rise. I was looking at there was a weatherization thing from the state of New York or something, saying, do these 5 things to make your house more efficient. Heat rises, do this. I'm like, no, sorry, heat does not rise. Yeah. Warm air rises. That's not the same. So here's my shtick. If heat rises, then I should be able to take a glowing hot red penny and put it in my hand. And as long as I hold my hand very flat, I won't get burned. That's not how things work. Heat goes from hot to cold. Hot air rises. Yeah. Okay. So I'm going to do that shtick one more time because I did not think I got that recorded. So the house is 3,649 cubic feet per minute at 50 pascals, which turns into 19.9 air changes per hour, 50 pascals, which is a simulated 22.5 mile per hour wind against the house, which is a 19-inch hole in the wall. If we took all those gaps and we put them together, that means that when there is a 22.5 mile per hour wind blowing against the house, every 3 minutes, all the conditioned air is blown out and replaced by outside air. Depending on the outside air temperature, that could mean 0 degree temperature air coming into your house that has to be reheated. Okay, I'm happy with that. Let me, I'm gonna keep this, chip. I have a second one. You wanna keep that with the camera just in case?
We'll get it next, yeah.
Okay. We're not doing
no, we're just doing a final blower door.
Exactly. I don't even have to finish my sentences. My wife calls Jim my other husband.
Very cool.
26.
When you've been with each other this long.
How many years?
Gosh,
well, 9 years we've been doing this together.
9 of those, yeah. It all started too because he had me do an audit at his house, and he was really interested in the whole building science thing, and I already had gotten involved. And that's why he wanted to do things to his own house, and my crew did the work on his whole house, and since then we've been doing audits together.
Yep. Fantastic. Well, you guys are a great team.
Thank you. You're right. We really do enjoy this, and
we enjoy solving problems, yes, but more importantly,
helping people.
Yeah.
That's seriously.
So if somebody's going to be
well, I mean, this is exactly what Bob's gonna want. He may not want some of the new. You know, I feel like you guys are doing a really comprehensive job.
Thank you.
And more of the work is going to be done behind the scenes, generating everything else.
Yeah, getting
the report.
Now, a couple of questions.
Yes.
As we're doing the house here, do you also end up taking a look at the little building next door and maybe at
We'd be
the
happy to take a look at
garage
them.
up there?
They're not a part of our regular. Oh, I just put that.
That is fine. I thought the barn is an electrical nightmare. And the sauna probably is.
Leaving the ladder for you.
So.
There's a soffit vent.
Oh, okay.
The soffit vent.
So we know.
Yes.
What we don't know is whether it's rigid or sure it's flex.
Oh, you're gonna assume it's
Yeah, I'm gonna assume it's flex too.
No, we usually what we do because see the way Efficiency Vermont categorizes it. The main building that is metered is a dwelling.
Yep.
Anything else beyond that is a separate independent.
Building.
Yes.
Yeah.
So they would
okay,
and
and
that's
that's
treat that
perfectly
separate.
all right. I'm just.
We certainly can give suggestions
Yeah.
on what to do. The
Oh,
vinyl,
yeah, we'd be happy to take a look
Yeah.
at it.
but the vinyl, yeah, that's in the way it's so close to the ground. From a durability standpoint, I'm concerned there.
Is there a place where we're able to take a better look at the insulation to the sheathing to the?
Really, just that back corner where I put my hand because that was like 6 inches off the ground. That was
Yeah.
the only spot I saw.
So after you guys issue your report, somebody has to do work.
Yep.
And so how does that operate in conjunction with the recommendations
Yep.
that you make?
So basically, if any rebate monies are going to be received for the work that is done, then I have to come back on a separate occasion to do a follow-up. To
Okay.
inspect, I mean, there's a slight charge for that because it's a long drive and I got to set up the blower door again. I don't have to do everything here, but I do have to get up and inspect.
Yep.
You know, make sure everything's done. So I'm putting my name to it, my certification, and I'm signing off.
Yep.
Efficiency Vermont calls that the process they want to follow, the protocol, and then we'll go ahead and send that to them. That allows you to know that the work was done appropriately and verify that the air leakage was reduced. Sure. That's where we're going now for the final blower door test, or over on the shore for actually ended up in a court case. It was a brand new build 6 years ago, actually almost 7 now, but it was a failure.
2014. I was looking at the original
Yeah,
report.
so it was a failure to start with. They weren't even living there. It was a retirement home. They would come up once a month, but the first heating season, keeping it at 50 degrees, they spent $3,500
Yep.
and they had frozen pipes just to keep it warm.
Wow.
So something was wrong. And so we went in and just did an audit and found all these problems. I ended up in court as a witness and was treated hostilely by their defense attorney, not the clients, but the other people, the builder. And it was just like, okay. And so we found all these problems, and it took 6 years to settle, $200,000 in legal fees just on their side. So that means, how does that consumer protection in the state of Vermont? Once again, unregulated.
Unregulated.
You know, no checks and
No,
verification.
no contractor registry. The build, and this was specifically a really weird situation because it was a builder.
Yeah.
The builder was not the maker of the house. It was a modular house built in Pennsylvania. It was, and so there were two people in the court case. It was the builder and the manufacturer of the home.
Because they were responsible to vet their contractors.
Yeah.
And they also marketed their assembly as the highest performing, efficient building that you can get, which it was basically barely code.
Yeah.
And it was actually failing in that. Because what happens is the bottom module comes in, shipped in.
Yep.
The upper one gets built on site, stood up and then put together and everything else. They were running plumbing pipes through cold knee walls, and that's why they were freezing. Just stupid things like that. The basement wasn't done right. There's just so many other errors. And here's these people. They're investing their retirement money into their final home, and this is how they get to start out on that endeavor.
Yep.
And so, yes, they prevailed after an appeal and everything else, but then they needed the work done. So I had another contractor that I respect and I have full confidence in do the work for them. But I made sure I was doing the hand-holding and said, this is the scope, this is what we expect, and this is how it's going to be done. Now we're going back to verified, but I've verified their work before and have full confidence in it. And we're going to just see how good the results were afterwards.
Yep.
And so in this process for your brother, depending on what he wants to do, how much carpentry is involved, how much insulation is involved, or both, a combination thereof, we can help source the right individuals to do the work, and I can verify on the other side. Sometimes if it's a small scope, I can handle it. Or if I just need to be the general contractor. Let's say he is out of state and you're down there in Mad River. I can make sure the contractors are doing the right things, and do that type of thing, because that's what I do every day. And can make sure that happens and do the checks and balances. And so we can run the project several different ways. So there are valid options out there.
And of course, we're in a place right now where contractors are off into 2022 with a lot of their work.
Yeah,
so
I'm pretty aware of that.
Yeah.
I don't know how it is up here, but the valley's crazy right now.
yeah, no, you can barely get someone. I just want to put in recommend wide windows. 4, 3, 2, 1. Okay, I didn't want to forget that. I know. So that was the last installment of that energy audit. That's a segment that we call the audit eavesdropping. We're actually doing another energy audit this weekend, and with the owner's permission, we'll be videotaping and sharing that with you. I actually got an email today from Guy Payne from the Sustainable Energy Outreach Network, SEON, down in the south of the state. He was talking about having had an energy audit done on his house, and I was rather disappointed with the auditor because the auditor didn't do the basic things, didn't measure the indoor humidity, and didn't do a walk around of the outside of the house. Went straight to the place that the two places that Guy had told him there were problems. So he called up Peter Yost, who of course is a building scientist, and he said, well, what Peter did is he came into the house and he set up a humidity monitor, and then he walked around the house. And I said, exactly, that's the first thing you do. The first thing you do is walk around the house. Now Peter sets up his humidity monitor first, and then he walks around the house. But we set up the monitor once we're unpacking that piece of equipment that has the monitor in it, which is after we do the walk around. But it's really important, and I think what we'll do is we'll at some point we will do an instructional video of what you as a consumer should expect when you get an energy audit, so you know when you're getting a good one or a bad one. But let's talk for just a second about that particular house, right? This is it was a single story ranch in a T formation on Lake Champlain. It's a beautiful location. House was built in the 1950s, but it had some work done on it that was completely cosmetic in order to sell it, and had some durability issues. It also had some very good points about it. What do you think about that particular audit, Jim?
Well, there's so much of this housing stock in Vermont, which really amazes me. First, when I moved up from Florida a quarter century ago, it's been a while, and you're used to tin cans down there, because I lived in one in 1974, single wide mobile home, and you just turned on your air conditioner more. And I thought, for sure, when you get negative 30-degree temperatures, no one's going to want to live in one of those up here. And I saw those. Well, those are much better than some of the houses we've seen. And you get some of these walls, and it's just amazing to think that the people. There's one that we did over in Jericho Center, that Matt's working on now in rehabbing. But you realize this lady who died not in the house, but she lived there from birth till death, and she was 80 some years old. And we come to find out that the walls had never been insulated, and that's how they lived. So they just
plank walls.
Heat and huddle. Yes, plank walls. So there's no room for insulation. So she would huddle in a corner basically, or wear lots of outdoor clothing indoors, and turn up the heat. But people live like that. So one of these houses like this, it was built in the 50s, and back then you had 2x4 walls at best.
It was 20 air changes per hour at 50 pascals.
Yeah, so you put some insulation in the walls, probably not installed appropriately, then it degrades over these times.
And zero air sealing.
Yeah, zero air sealing, the attic wasn't good, all these types of things, and people have been living there. So someone buys this new, and then you've got to give them the after the fact analysis instead of before the fact. Now, see, here the thing is, Chris and I do not try to dissuade people necessarily from buying a house that has issues. We did once. Yes, but we don't normally try to do that. People, because some people, like realtors, are afraid to have some advice from somebody like us, because they're more than happy to have just a standard house inspection. And there's great housing inspectors out there, but there's a lot of them who are just checking the box, making sure there's some eyes on it. The mortgage company's interests are protected. They can make the sale, great. But there's a lot of them that they just don't put the eyes on there that they need to. And so you see these type of things. And when we do, we say, okay, listen, to the prospective home buyer, you're going to need to do this. If you're going to make it not to the Cadillac nth degree gold standard, but you're going to make it efficient, you're going to make it safe, you're going to make it durable at the same time. These are some of the things you need to consider when you're purchasing this home. If we get to tell them that before the purchase, then they can negotiate that into the arbitrary price that someone came up with for the value of the home, and then they can still get the work done. The sale still goes through, instead of having the sale happen like this one did, and then saying, hey, now come in and take a look and tell me what I need. Heating system.
Oh my gosh. It was a mixed fuel. So there are some old systems out there. This may even be an original system to the house. This was an oil, coal, and wood burning boiler with an efficiency that was bad, and it was running when it was. Oh, we turned all the thermostats off.
Oh yeah,
and
in
it was
the summer.
Still on.
Yeah.
It had two 275-gallon tanks. I mean, if you haven't watched the other bits of the Eavesdrop, the Audit Eavesdrop, this is a 1,400 square foot house that has 550 gallons worth of fuel, which is twice what any house should need. And you shouldn't have to fill that more than twice, maybe 3 times in the winter.
Correct.
Yes.
Well, here's the thing. That was bragging rights. Because remember back in the day, the 1950 muscle cars, they could say, hey, I got dual carbs. Hey, I got dual fuel tanks in my 1950 now. So maybe that's what they were doing.
Classic.
Don't the lights go off for somebody saying, something must be wrong here? Turn one of those fuel tanks into a barbecue, a smoker.
Yeah.
Make that house more efficient. But to make this house more efficient, it's not an easy undertaking. Certainly the best area was the attic.
Yeah.
Get that done. It'd be much better. Next would be the walls. But there's compelling reason to address the walls because some of the windows were rotting away. And that was transferring that water into the framing.
Dumping water into the wall. That was
exactly.
that was episode 1, by the way, if you want to look at that again.
Yeah.
Some serious durability issues. The thing that surprised me, and this was my favorite part of the episode, was going up into the attic and seeing unopened rolls of insulation just stuck somewhere in the attic. And all I could think about was that Efficiency Vermont video they made showing how cross-hatching fiberglass was a perfectly good way to do attic insulation.
Hey, but as you said during the audit, that one spot, that 2-foot circle, was an R60.
Maybe even an R150. That 3 foot diameter circle. Yeah, and I'm not bashing Efficiency Vermont.
No.
Efficiency Vermont is a great organization, and that is just. I reserve the right to disagree with them about certain building science concepts, and that's okay. We can disagree. But this is like piles of insulation in the attic that were just laying there. Somebody had moved it into. There were like 4 of these, 4 foot tall, 4 foot wide piles there, and 1 roll of completely unopened insulation, which was hilarious because the week before we had been in St. Johnsbury and we'd seen the exact same thing.
Exactly. Well, see, here's the thing. The analogy to that is some people think, well, gosh, I've got all this insulation in my attic. It must be efficient. I can't be having problems. And what we tell people is if you didn't air seal first and you have 4 feet of insulation in there, you might as well take that same insulation.
Just throw half of it away. Yeah.
Yeah, throw half of it away or put it in your garage. Then you can still say I have all this insulation on site, or in this case, I have the insulation in my attic, but it can't perform well.
Yeah.
It's there. Yes, you're right, but it's not getting you the performance that you're looking for.
It's just. I think putting it in the garage is a perfect analogy because you might as well just put it out in the shed because it's not doing nothing.
Exactly.
So hopefully next week after this audit, and if we can get permission to do to use the videotape on our show, we'll continue with the audit eavesdropping because I think it's very instructive for you all as our audience to see that. So we're going to just now take a slight detour over to 10 Old Stage and take a look at how things are running there, and then when we get back, we'll watch the interview with Jacob. So we'll be right back. Hey, this is Chris West from House Calls Vermont. It is the 27th of the July month, and I am here at 10 Old Stage. This is a 10 Old Stage update. I've got Sebastian and Jack up on the ladder. They're working on a problem which I pointed out in an earlier video, which is the top of the window buck up to the bottom of the supporting piece of wood. I've showed you this before. Right now, Jack and Sebastian have jacked up the floor off of the seat. So Jack, can you point out that seat, just the wood seat right there? Yeah. This, so that piece of wood is what the floor sits on. Right, that piece of wood. You're right, exactly. And it was rotten from where it's cut off all the way to the corner. So we were going to take a piece of PT and we're going to replace that so we can drop the floor back on top of it. And that's the plan there. But when we opened that up, there was an open gap between the outside layer of brick and the inside layer of brick, which we want to fill with concrete. So right now, Sebastian has been mixing concrete, and Jack and Sebastian have been taking turns bringing in very small amounts of concrete to fill this very large area. So it's taking quite a while.
If there were a better way to do it, we would do it.
Yeah, but it's gonna be a really good assembly when we're done. We don't have that problem here, because here, this piece of wood, this one here, is actually what was missing over there, and that's what we're filling up with concrete. So very happy to have that done. And then on the connecting and attaching the, yes, outside noise, the outside plywood to the wall. So what I had been doing, but has not been very effective, and has given me quite a lot of pause, is I've got a 12-inch brick wall. That 12-inch brick wall, you think you might be able to put some fasteners drilled into the wall that will then pull it up. But the problem is that the brick just isn't strong enough. What I'm finding is that as I do that, using a really good aggressive Tapcon with the right sized drill bit, and I'll show you what I mean. So here is the Tapcon, right? This one is a 3-inch or 2.5, and that would be mostly in the brick. But what's happening is, as I'm drilling it in, it may grab. First of all, I have to drill 2 or 3 holes to find some brick that's strong enough to actually take it. But when I do screw it in, as you can see here, I had to unscrew it, because although it'll grab at the very end, if you go even a little bit further, it'll completely release and won't be doing anything. And I'm not comfortable hanging all of that exterior insulation on this wall with just some Tapcons that are not seated very well. So what I've decided to do is I've decided to do rods through the wall. And there's the first example. This is a 5/16 threaded rod. I'm drilling right through the brick. On the inside, I'm putting a bolt and a washer. And on the outside, the same thing. And what that's allowing me to do is to squeeze that gap, the air gap between the brick, and I can show you that here. Here we have, this is just hanging here, right? So this all has to be attached as well as possible to the surface of the brick. I don't want an air gap back there, which can cause, give a place where condensation can happen. This is PT, and the brick is obviously not going to degrade with moisture over time. And all that water can condense and leak out of the bottom. There's nothing stopping it from doing that. But I'd like to get this plywood as tight to the brick as possible. And the way I'm going to do that is I'm going to be using this assembly, because that works. So I'm going to be doing 4 of these on each 4x8 sheet of plywood, 2 kind of, one here, one there, one there, one there, and in between I'll put some Tapcons just for some extra holding. In the end, we'll probably have 4 super all the way through the brick supports, and that's great. And there will be places where I'm using the Tapcons, but because the Tapcon is not actually holding the or closing the gap, the threaded rods are doing that, then the Tapcons are not going to have that much force pulling them back out, and they should be more effective. And next week, Saturday, we're going to be getting our our windows for the downstairs windows delivered. And that's very exciting. And then next week, during the week or the weekend after that, Jim Bradley and I are going to be doing a video on how to install these windows, and that's going to be a really exciting one. So that's all for right now here at 10 Old Stage. The update on what's going on. I've only got another 3 weeks of Jack. Jack's going on a, what is it, a 2-month sailing adventure from Amsterdam down the coast of Europe, down across the Straits of Gibraltar, all the way to Cape Verde, and then the middle passage across the Atlantic, the shortest space between Africa and South America. And then they're supposed to get off at Montevideo and fly back. So that's Jack's leaving on the 17th. So I've got about 3 weeks before Jack is gone. Sebastian's going back to school next week, so I'm going to have a lot of time on my own. There was something else I wanted to show you. I don't know if I was able to show you this on the last video, but we took part of this garage. This is the garage that's attached to the wood part of the house, and we took an 8-inch or 10-inch, maybe I guess it is, hole between that wall and the wall we're insulating, so that we can continue the plane, right? The insulation plane. We wanted to start at the brick and come all the way to the wood part. But what we found is that this beam is completely rotted out. So that beam has got to be replaced, and the beam that it's on, so there's a beam on the ground and there's a beam like this. The beam that's on the ground for the first 3 or 4 feet is also rotted. So I'm going to pull that out, replace it with either a built-up PT assembly, which is what I've done in other places, and that works quite well. And I'm going to take an old beam that we have that we've taken out of this building at another point, and I'm going to replace this beam right here with that, so that, you know, it'll be nice and structurally good. And then we'll also bring the plane of the wood building into the same plane as the brick, and that's here. So that's into the future, but this hole was cut so that the insulation can continue from the brick building to the wood part of the building. That's about all for right now. This is Chris West for House Calls Vermont. Until next week, with an update from 10 Old Stage on the 27th of July. playing? Is it not playing? Oh. Sorry guys, a bit of a mix-up there. I forgot to link the source to that. So let me just quickly go in and do that. I apologize. I just got to go in and browse to the place where I store that. A little bit of a hiccup here. House Calls Vermont, interviews, Jacob Racusin, energy embodied part. There it is. And go OK. And then we go bunk and we go transition. And there we go. Sorry about that, guys. Interview with Jacob Racusin. Welcome, Jacob, again to House Calls Vermont. We have the same clothes on, it's the same background because we're just continuing the same interview. It's not like we're still sitting here a week later with the same, although who knows, knowing the two of us.
It's a comfy zip. I wear it a lot.
That's true. So part two. The part two I wanted to start getting into is this really contentious thing in the industry right now, but something that we've been really needing to talk about for a very long time, and that is, what are we actually trying to do with these attempts at reducing carbon emissions, right? Because we've agreed as a society here in Vermont, maybe not broader, but in Vermont, we've decided that climate change is real. Global warming is, well, we're calling it climate change because it's not just warming, it's also cooling depending on where and when. And something that Jacob has had on his radar for a very long time is looking at what we're actually doing as far as our building materials and how those either add to or subtract from our stated goals of trying to reduce carbon emissions, and has written books and spoken at conferences, and we're just very lucky in Vermont to have him and Ace McCarlton and others who are working on this, so I wanted to dive in a little deeper and start off by saying, what do you mean embodied energies? What is it that we're trying to look at here? And why is embodied energy and embodied carbon important in our societal move towards trying to reduce our carbon footprint?
Great question. Thank you for the opportunity to talk about it, because it is such an important piece that we just haven't really. It's been a blind spot for our industry for quite a while. So just some quick definitions of terms. That embodied carbon is really a shorthand phrase for embodied carbon dioxide equivalent. And that carbon dioxide equivalently speaks towards all the greenhouse gases that are emitted from really the entire life cycle of a building or of the products within the building, and all the points of emissions of all the different chemicals, carbon dioxide being one, including methane and a host of different refrigerants that are in some cases thousands of times more potent than carbon dioxide.
On an ounce per ounce basis, yeah.
Exactly. Yeah. So when we say embodied carbon, it's really shorthand for like the greenhouse, the global warming potential of a building or of the products in a building. And that there's a very formal practice, life cycle analysis, that really looks at the entire lifespan of a building from the when. Wait a second.
Did you just equate the lifespan of a building to psychoanalysis?
I know. I spoke too quickly. Life cycle analysis. Although, oh man, does psychoanalysis enter into our work on the regular? That's more client relations. But also internal meetings have a lot of that too.
Yeah.
No, but no, when we're talking about the atmosphere, life cycle analysis, I love that. That's hilarious. That's the like methodology of looking at full life cycle impacts from when materials are extracted out of the ground or harvested from the woods or a field, all the way through the operational phase of the building until the end of life scenarios and conditions and emissions that come from demolition and decomposition of materials and whatnot.
Cradle to cradle, as it were.
Yes, exactly. So that's like full embodied and full life cycle. What we've been working on more specifically, both because it's a little bit of an easier nut to crack, but really because it's what matters right now, are the upfront emissions, which are the emissions that happen in the life cycle of a building prior to it being occupied. And so we're looking largely in where the materials come from within that sort of time frame of reference. And so a lot of that's what we call cradle to gate, which is essentially looking at the products themselves and what emissions and global warming potential is realized from the development of these materials. Again, from getting iron ore out of the ground or cutting that timber down through all the way through the transportation to various facilities and the manufacturing of those products to the point that the product is done and ready to leave the factory gate. And so we talk about embodied carbon, that's generally what we're looking at, and partially because there's really good data that's available now to look at those products and compare them directly. And the boundaries are constrained enough that we can have a pretty good evaluation standing of like, oh, this board installation is 25 times the global warming potential of this one. And that's like actionable decision-making data. And partially because what we recognize is the global scientific community has flagged initially 2050 as the deadline for decarbonizing our industry if we're going to have a stable planet in which our societies we know it to be able to continue. Now I'm hearing those being revised to like 2030 to 2035, which is an incredibly short period of time. And so when you look at where the emissions are of built infrastructure between right now and that period of time, the majority of them are in the production and development of materials, not in the operation of buildings.
Right, because
and that's partially
all
because for a
working
long
very
time it was all
hard.
about the operation.
Yeah, we're all working very hard to reduce the operational energy that our building has. That's the whole
Yes.
basis of high performance and passive house and those types of things.
Exactly, and we've been really successful, and that work needs to continue. I in no way mean to say that we're done and it doesn't matter anymore and it's less relevant. Like, no, everything we've been doing and more so needs to happen around improving energy performance of buildings. Right. And what we're realizing is that's not, and in addition, the environmental impact of our energy production is critical. So decarbonizing the grid and fuel switching to low emission fuels, huge, critical, fundamental part of it. Like, yep, all that, absolutely. And we have to consider the impact of what it takes to develop our materials as well, partially because it's the largest category within this near period of time, and partially because the scale of those emissions can grow as we pursue improvements in the operational performance of our building. So if we're using more insulation and really high levels of insulation and using different types of air sealing measures and whatnot, and those have really significant climate impact factors, like we need to know that and plan for that accordingly so that we're not erasing all the gains from reducing our operational performance by blasting thousands of tons of refrigerants into the atmosphere in the process through producing refrigerant intensive insulation products. So that's when we're talking about embodied carbon, like that's what we're trying to understand. Like, yes, we're getting a better understanding now than we've ever had around why energy efficiency in building operations is important, and why this move towards all electrified buildings and renewably powered grids is really important. And we're saying, and it's not enough.
Right.
And if we were really doing the work we're doing now in the 70s and sustained that from when we started doing this work as an industry in the 70s and stayed there, we probably wouldn't have to talk about any of this embodied carbon stuff. It wouldn't be relevant. It would be a blip on the radar, or maybe we'd have a lot more time to think about it and more options available. But we squandered a whole lot of time and a whole lot of our carbon budget. Yeah. And so now we don't have the luxury of like only looking at operational energy anymore. We really have to think about where materials come from if our actual goal in doing energy efficiency work is to reduce the climate pressure from building buildings.
Right. So tell me, you've got. I remember you came and gave a presentation like 5 years ago to the Northern Vermont Building Science Group with the spreadsheets, and you were looking at all the various bits from that cradle to gate. And it fits really well in with the new framework's idea of natural materials, because those natural materials are very low as far as I understand on that scale of embodied energy or global warming potential, whatever term we want to put there. Tell me, what have you found? I mean, I don't think any of us will be surprised that highly plasticized insulation materials are not doing very well on that scale if the scale is trying to reduce that. So give us just a 30,000 feet view of what your research has found.
Yeah, happy to do so. I'll try to kind of hit the bullet highlights, knowing that there's exceptions to everything and a ton of detail, and we're still learning some of these patterns. But some of the patterns that we've seen, structure is a really big deal. It's less of a big deal for low-rise residential construction and light commercial, where a lot of our structures are already, small wood sticks, and that's pretty light impact. And so that's great. And the structural pressures on smaller buildings are better. But there still is a ton of emissions that come from concrete. And there's a lot of work we can do to reduce the emissions of concrete without costing basically anything, if anything, in many cases, saving money by being able to design out waste. And certainly as you get into slightly larger buildings, you start getting into any more steel construction or concrete structure beyond just foundations. Now we get into really escalating levels of emissions from structure. And so paying more attention to structure and structural engineering and structural material alternatives is really important. More apropos towards the sort of home builders and remodelers, kind of residential and low-rise scale work, insulation materials jump out pretty significantly. Partially, again, like I was saying before, because we're using more of them in pursuit of low energy buildings, and partially because some of our worst offenders and our largest spread of impact is within the insulation products division. And we actually have a lot of choice around insulation products, like cavity fill or continuous wrap or foam application. Right? There's 1,700 different insulation choices out there for how you want to strategize conducting a building. Some of the worst offenders are HFC-based spray foam and XPS foam board have refrigerant or propellants that are the classification.
It's classically called a blowing agent, right?
Yeah, blowing agent. Thank you. Exactly. Is used to formulate those products. Those have some of the highest global warming potential and profiles of any of the chemicals you bring into the built environment. And so those insulation materials are really, really bad from a climate perspective. And then you got a whole bunch of stuff in the middle. There's a lot of foams like polyiso or EPS foam that are pretty intensive, but way better and more moderate in their impact. You have mineral wool. It's actually more than the lower level foams, but not as bad as the high chemically intensive foams that sort of stack out there, because it takes a lot of energy to spin stone into wool. Yeah. And so there's a lot of emissions associated with that. And then you kind of keep working your way down. You've got more bio-based materials, and you have products like cellulose, which is almost entirely from a waste stream. And then you've got agricultural products like straw or hemp that are showing up in off-the-shelf bats, prefabricated panels, custom processes, etc. And those, now you get to the point of being able to do active carbon storage, where we're using the fact that these short cycle plants or bio-based waste products, that the 50% of their mass is carbon that used to be carbon dioxide in the atmosphere that's photosynthesized into the body of that plant. And so now we get into the potential of actually carbon storing materials if we can really ensure that they're coming from a well-managed site, and that's a legitimate, they're not creating more emissions than they're actually storing in the plant itself, et cetera, et cetera. So we see insulation materials that offer that advantage. And so we've had some clear worst offenders. We have some clear winners, and we have a bunch of stuff in the middle. And then there's wood, which is everyone's really big, oh my God, in using wood, are we deforesting the planet, or are we storing a bunch of carbon in our buildings? And the answer can be yes, to both of those, right. Sometimes in the same product. Right. But really ultimately, in terms of the larger carbon balance, it totally depends on how that wood resource is managed. And so on an industrial scale, it can be really hard to make sure that that's good wood from a plant standpoint. Here in Vermont, where we're using wood from smaller scale managed plots that tend to be managed for the long term under management plans by legitimate foresters. In those cases, I feel a lot better about the use of wood, but that's a difficult thing to scale nationally. And so we have an advantage of being in a region where that resource is available to us. so when we're really looking at embodied carbon in buildings and residential construction, there's some pretty good worst offenders. We can say like, yep, we're going to try not to use those materials because we know they're really bad. There's other ones we can say, these are great. Biobase is really good, and short cycle ag crops like win all the time. Right. Structure is kind of an issue. And then I think the other sleeper hit there is that in cladding and interior finishes, we can see, again, huge pools of carbon or huge pools of emissions, depending on whether you're using bio-based materials or high emission intensive materials. So fiber cement siding is an enormous climate footprint to that material relative to working with native cedar. And so there's we can talk about longevity and durability and maintenance and aesthetics and all the things, absolutely. But if we're looking at this in the lens of what is the climate emissions from this building, we care about that, we're going to make any decisions around that, or at least want to come by that honestly and understand that, then getting into some of those details of some of the finishing systems, like there's a lot of material that goes on the wall. And again, a really big spread of what the impact of that material is. And so we've been working a lot of recent in terms of like, well, now what? We've been working on better tools to be able to have some reference points of what the worst offenders or best options are and where your preferred materials lie in between. So we can really start with a sense of smell, as well as actually accounting tools that we can bring into our design or construction practice to be able to start doing some of those tallies and doing some of that basic accounting to just so we know what our impact is. It's just what folks in the energy efficiency world have been saying forever is that you can't manage what you can't measure. If you don't know that you're bleeding energy out of somewhere, you don't know whether that valve should be on or that switch should be shut off. Right. So a lot of it is just like we're at the point with carbon now where, embodied carbon emissions, where we're still trying to understand what our impacts are, right, and where are all the big emissions and what are all those big patterns. And so a lot of us that have been more on the bleeding edge of that are trying to do the heavy lifting on the accounting work to really understand, just doing a bunch of like looking at a lot of our buildings and looking at all these new materials and really just trying to dig in and tunnel through and help just make that more evident to ourselves. Because we know the problem is really huge and we know that the emissions are enormous and we know the potential for carbon storage and working with sustainable agriculture and silvicultural systems is in one of the most exciting and like largest potentials for climate action in the built environment is working with bio-based natural materials from sustainably managed land resources. Like, oh my God, that's thrilling. Like here we go in terms of like looking, where are the big solutions? Like farming and forestry. Like every rural community in North America should be like trumpeting this from the mountaintops that here, the solution lies in existing ecological systems of photosynthesis with these industries that are the backbone of American industry since the founding of the country. Right. We should be able to rally around that. So that's a really exciting potential. Where now it's just a matter of understanding. We know that's all true. Now it's a matter of like, okay, what's the fastest way to get there? What's the most what are the worst things we need to design out? What are the best opportunities we need to throw leverage into? And what are the general patterns around what we should care about? Like, is it worth obsessing over our drywall? Sometimes yes, sometimes no. When, why, how much, what else have we done first? What else should we be paying attention to? It's like that old adage that, if you're worried about moisture in your building, like don't worry about a vapor barrier until you've gotten your window flashing right. And then don't worry about your vapor barrier until you've gotten your air barrier. Like there's a hierarchy of importance. And like we know what that is in energy efficiency. We know we're not gonna head into our first weatherization project like, oh, clearly these windows need to get replaced. Like, well, actually, no, because that's really expensive and only saves so much energy. And there's like that we've learned some of those patterns after a generation's worth of like full industry weight behind us. We're still working out those patterns so that we don't all have to do the accounting right now. So that's my 30,000 foot.
Yeah, that great. Yeah. I mean, you're in the airplane looking down. So that leads me. You have such a good storyline that I was thinking, where's the tool? And then you started talking about the tool. So my question is, and by the tool I mean, where are you at in having an actual deployable tool for a contractor to be able to take and say, I'd like to take a look at the embodied energy of my materials. Jacob and his team over at New Frameworks have put together this spreadsheet, this online whatever. Is there a tool available, or are you developing one, and where's that at?
Yeah. The answer is yes to both of those. So there are some tools that are out there right now. If you're in the design world, for those of you that are that either work with architects or are an architect yourself and work with Revit, Revit has a great tool called Tally, which does life cycle analysis. There's another competitor, OneClick, which is not specific to any particular design program. So those are the architectural resources that's out there. There's a free tool that's out there for everyone called EC3. That's released by Building Transparency, pardon me. And that is essentially, it's an awesome tool. It's basically a database of environmental product declarations, which are essentially like the nutrition labels for buildings that look at their environmental performance.
It's very big in the living building challenge. Those
yes, that's all about like supply chain transparency and product transparency to know like, well, what is the global warming potential of this piece of drywall? There's an EPD, environmental product declaration. It's either been released by the company or by the trade group that will give that data. And so EC3 has combined thousands and thousands of those EPDs together in a tool, an online tool that's searchable and allows you to model full buildings or compare between different products. It's more scaled towards larger, like more commercial development. And so it's a little bit intimidating. It's not the easiest thing to use for
residential.
Exactly. But I do know plenty of folks in the residential market, myself included, that use that tool. And it's a good resource for like, I need to find like, what's a good drywall solution? You can you can use it for sort of targeted product research. And if you're more like tool oriented in your nature as a practitioner, then like it's totally usable and approachable. It's free, open source, with lots of good documentation, a strong community of users. So that's something that's available like right now you could get into like today. Athena Lifecycle Impact Estimator is another free full lifecycle tool. It tends to get like not be the best user interface in the world and has a more limited database in terms of potential materials. Like there's a lot of more alternative materials that aren't going to show up there, but it's another great, pretty usable, free, straightforward tool for, again, that's full life cycle. So you're not just looking at global warming potential, you're looking at 7 different impact categories over the full lifespan of a building. But that's, again, something you can use right now. What I'm talking about in terms of the upfront carbon emissions or carbon dioxide equivalent embodied carbon emissions of a building, and really focusing in on that. That is a tool that I've been working with Chris Magwood from Builders for Climate Action for a couple of years now, called the BEAM tool, Building Emissions Accounting for Materials. That emanated out of a thesis, a graduate thesis that Chris did around this topic, and he actually built out this enormous database of EPDs and a working tool for himself for his own research. We then since spent the last couple of years improving and refining, going through multiple levels of revision. There's essentially a working spreadsheet model that exists right now, and the web application is under development to be released imminently. There's I don't know exactly what the release date is at this point, but we're within spitting distance.
Awesome.
The spreadsheet is pretty much ready to go. And so if you go to Builders for Climate Action dot something, hold on, I can look that up.
I'll get all of the links for all of these.
Yeah,
tools,
you get the link up there. Builders, Google Builders for like Climate Action, and you can sign up for the release notice on the BEAM tool. And that'll be a web application that'll essentially, you can say, you'll input the basic dimensions of your walls, ceiling, foundation, kind of like a super lightweight energy model.
Like REM rate, but for embodied energy.
Exactly. Yeah, your basic building dimensions. And then you can, within the tabs in the tool, you'll be able to see a listing of all the different material solutions for bat insulation, board insulation, interior cladding, exterior cladding, et cetera, et cetera. You can see what the carbon profile is for all those materials based on the amount of insulation that you're asking for and the area of the room, and then click on the ones that you want to specify for your project, and then it'll total them. So you can see the comparative analysis between different options and then the total of what your building looks like. Because let's be honest, we're still going to have to be putting spray foam in rubble basements forever, or at least for a long time. Like there's really not a better way.
Yeah, they develop a non-plasticized spray foam that does the job.
Yep.
There are some places where you don't get better than what that stuff does when it's applied correctly.
Right now, this is kind of what we got for at least right now until some better solutions show up. And so if you're then also going to be touching the above grade walls, touching the attic, you know, re-skinning the building, are there other material choices you can make to offset the impact, to balance out the impact of that spray foam? So if you say, like, we want to keep this building to a carbon budget and you invest more of that budget in the foundation, the point is not to say no foam ever, foam is bad, and come up with like a dozen reasons why there are some serious liabilities or concerns around that material, but then there's another dozen of why it's like actually really important and a good tool in the kit. And so the point of that calculator is to be able to
visualize
absolute
and put actual numbers behind your feelings about it.
Yes, a data-driven approach to making better climate choices for material selections. And the one thing I will say is what I was saying before, that like, yeah, we're still a little bit green in this work. We don't really have all those patterns identified. We can't just say this is good, this is bad. I mean, I've been looking at this for years now, like pretty intensively, and I'm still surprised on the regular at like what I thought was going to be a big deal is actually not that big a deal. Or what I thought was like, oh, I shouldn't have considered, like, oh, wow, there's like, oh, it makes sense. There's like 7 square miles of drywall in this building. Okay, yep, I guess we should probably pay attention to where that's coming from. And like, do we need 5/8? Because we can go to 1/2 inch and 20% of our emissions just went out the window, so to speak, because we were able to make do with less material, and that's also cheaper. You know, those types of things.
Yeah. Well, so I am going to get all of the links that, to the various programs that you spoke about, the online and the others. Is your tool, the Beam tool, going to be a free, or is it going to be something that people will have to pay for to use?
The Beam tool right now is designed to accompany a membership as a membership benefit of joining Builders for Climate Action. And that'll be, again, when that, I don't know that part of things. I've been more on the technical side of that development. But the BFCA is being established as essentially as a trades organization, professionals organization of folks that want to see this work progress. And so there's a lot of education, policy, development, research. The work that's happening in that organization is pretty terrific. So the tool, is designed to essentially be another benefit of membership to that organization that'll allow you your own accounting. My understanding is that there's there's a version of this in which there is a really lightweight kind of free version, and then more features get unlocked with more membership. But I'd say stay tuned for the release dates on that for all the gory details when they're finalized.
And I would recommend to any viewers who are interested, Jacob and Ace, and what's his name again? The guy from being
Chris Magwood
gave a presentation at the, I believe, 2019 Better Building by Design. The keynote speech was speaking specifically to this project. So and Jacob and I both have been colleagues. Have been fortunate enough to be colleagues on the RBs, the Residential Building Energy Standard Code Update Advisory Board, for the past 3 iterations, and that's an interesting organization and group to be a part of, because of course there's a lot of stakeholders who have competing goals, but for the first time a majority of us did vote to push maybe some points for embodied energy reduction. So toe in the door, as we say.
And that work is exploding. The policy level work around national governments, provinces, states, municipalities, starting to bring embodied carbon into their regulatory environment, into the code environment, like that is absolutely happening, and is going to be only more and more and more of that. So for any of you policy advocates or policy makers in the room, get on board now. Better to be ahead of this curve in designing policies and systems and structures that actually make it work for tradesfolk to be able to do this accounting in a way that's supported and not just another burden of bureaucracy or administration, but is actually like good tools to make smart choices. That's what all of this is really about. So yeah, keep your eye on that space. Thanks for mentioning that, Chris. That's really a big part of it.
And really important is that there's a shift in the builders that I've been dealing with for the past 10 years, where things that before they were ha-haing about, like a guffaw, these things are no longer guffaws. And so the maturation of the industry towards building science, towards understanding that we have climate goals that we have agreed upon as a state. I did have a guy who wrote this nutty response to something that I had said about, we have agreed upon, he was railing against the comprehensive energy plan. I said, dude, this is done. This is not a debate. If you don't like it, you cannot like it. But let's not renegotiate the comprehensive energy plan goals, because they've been part of state law for 10 years now. And if you have a problem with that, then it's not with me. It's with the legislators. Go to them, have them repeal the law or change it or whatever. But when I say we're doing this to fulfill state law, this is a law. If you're a law and order kind of person, either support the law or change the law. Yeah. So, yeah, absolutely. Well, Jacob, I'm really looking forward to seeing and playing with some of these tools in the future. Part of the Passive House, panoply of things that we're trying to point people to, we've been saying embodied energy and global warming potential for forever, so that this is becoming more and more part of the everyday nomenclature. When I hear a large local builder say something like embodied energy, just makes my heart sing. So we're slowly but surely bleeding from the edge into the mainstream, and your work is not a small part of why that's happening here in Vermont. So I want to personally thank you for those efforts, and thank you for taking time out to talk about embodied energy. And I will have lots of links for people. So that
Chris,
is.
Thank you. Real pleasure.
Yeah. Oh yeah. Say that. Go ahead.
Thank you so much. I really appreciate you caring and taking this issue seriously, and for opening up the conversation. Really appreciate it.
Absolutely. And I want every person who is a member of the New Frameworks LLC to go to House Calls Vermont and like and subscribe. Okay.
Love it. Great challenge.
Okay.
Appreciate
now we're
that.
gonna have a crew meeting, and you have to go onto your phone. And first things first. Let's get Chris fed.
First things first.
We're all volunteer. There's nothing going on here. So this is Chris West for House Calls Vermont. Jacob and I can talk for days and not get bored about probably just about anything. So until next time. Okay, you got us. I forgot to turn the mics back on. That's what you get for producing your own show. So I apologize for that. We'll just recap. So just to recap, that was Jacob Racusin. He's a great guy. We have two more videos that of the interview. So we interviewed for like 2 hours. It was super long. But he was energetic and excited the whole time. So this week we talked about embodied energy, and we will be having links to the calculators he was talking about when they're available. Next week we're going to be looking at heating systems and heating and cooling, of course, because a lot of these do allow heat pumps and other things allow for heating and cooling. And we'll also be doing a deep dive with Jacob Racusin about over a radiant ceiling system. Now, Jacob and I took a course together. It was called Integrated Heating Design on Heat Spring. It was a course that was given by Robert Bean, who is one of the authors of the ASHRAE 55 standard, the comfort standard. Fascinating, really deep dive into some physics about radiant heat, other types of heating systems, about useful energy. It gets pretty deep, but we don't go very deep during the interview.
Yeah, it's not your parents' wood stove anymore when considering radiant heat. That's So, and you're not going to put your radiant wood stove in the ceiling anyway. It'd be very problematic.
No, but we will be talking about the difference between the systems that produce energy for us, either heating or cooling, and the systems that distribute those, and the radiant ceiling is a distribution system. So we'll be talking about that, and next week's interview will be with Jacob Racusin about his experience with that system, because he installed it in a house. So we'll hear how that went and what kind of design principles he used. So until next week, this is Chris West.
Chris,
Yeah.
Well, I was just going to ask you a question, Chris. Not to get out of sequence here, but can we use one of those Tahagi on-demand domestic hot water boilers and use that to go ahead and heat the whole house too at the same time? So when you turn on the spigot, it has to go through the entire house first, right, and then get to the spigot.
So, so we can't just leave that one sitting there. So, one of the earliest energy audits that Jim and I ever did was this house, and the gentleman had put in a radiant floor system, and that radiant floor system was designed, and the entire package you could buy online from this company, and you would just get all the piping is already done. It's all been sweaty. Just put it up in your closet and add a Tahagi on-demand hot water boiler, right? However, tiny, yeah, not very big, not high BTUs, and what the customer was complaining about was how it took a very long time to get hot water when it wasn't the heating season. And what we realized by putting the IR camera on it with the heat on and the faucet on is that the way they had plumbed it is that the drinkable water, right, the potable water was going from the boiler through the entire house's domestic floor heating system and then coming out. It took like 10 minutes for the hot water to get to the tap point. And we discovered why. We were able to tell him where to put in a switching valve, and now he should not be drinking water through his radiant floor system, piping, etc. Thanks for reminding. It's been a long time since I thought about that one. That was pretty sad. And I think that company still sells those systems. So
it does. So I'll complete what you were saying. Chris already said goodbye, but for this week, thank you for joining us, and those who are watching after the video and at another time during the week or months or whatever, thank you for being here and have a great week.
Till next time, guys. Bye.